What if you lived on Neptune? You won't last a year on the planet because one Neptune year is 165 Earth years. But that will be the least of your worries because you will have to cope with some of the most terrifying things in the universe the scientists just discovered on the planet. Why are these discoveries frightening, and can humans ever step on the planet? Find out in this video as we bring you scientists' new but terrifying discoveries on Neptune that change everything we know about the planet. For many reasons, Neptune is not your regular planet. It is the only planet to have been discovered by mathematics. How does that happen? Well, French astronomer Urbain Le Verrier noticed irregularities in the motions of other planets, and from these perturbations, he calculated that there must be an eighth planet lurking out beyond Uranus. Even more controversial has been who takes the credit for discovering the planet. The first person to have seen Neptune was likely Galileo, but since he erroneously marked it as a star in his drawings and not as a planet, he is not credited with the discovery. Depending on who you prefer, the credit goes to French mathematician Urbain Le Verrier or the English mathematician John Couch Adams, both of whom independently predicted that a new planet would be discovered in a specific region of the sky. So when astronomer Johann Gottfried Galle actually sighted the planet in 1846, both mathematicians attempted to take credit for the discovery. To this day, you will find English and French astronomers battling over who made the discovery first. But of course, the two men can share the glory as far as we are concerned. But that is not an end of the controversies Neptune has found itself in, although this next one is due to no fault of the poor planet. When it was first discovered in 1846, Neptune became the most distant planet in the solar system. Fast forward to 1930 and Pluto made its own entry into our consciousness, moving Neptune into the position of the second most distant planet. But Pluto's orbit is very elliptical, meaning there were times when it actually orbits closer to the Sun than Neptune. So Neptune was destined to pop into and out of the position of the most distant planet. The last time Neptune got behind Pluto was in 1979, and the phase lasted until the turn of the century. But of course, scientists wouldn't just let Pluto be. At the General Assembly of the International Astronomical Union of 2006 in Prague, the issue of which was the most distant planet was visited once again. Thanks to the discovery of many Pluto-sized bodies in the Kuiper Belt, namely Eris, Haumea, Sedna, and Makemake, and then the case of Ceres, the IAU decided to tweak the definition of a planet. This move would cost Pluto its planethood, as the Congress agreed to define a planet as a celestial body orbiting a star that is massive enough to be rounded by its own gravity, but has not cleared its neighboring region of planetesimals and is not a satellite. More explicitly, it has to have sufficient mass to overcome its comprehensive strength and achieve hydrostatic equilibrium. Pluto failed one of these criteria and suffered the ignominy of a demotion to the status of a dwarf planet. The implication for Neptune was that it once again became the most distant planet from the Sun. The reclassification of Pluto was controversial, but for now, Neptune is the last star in the solar system. Neptune is more than 30 times as far from the Sun as the Earth. The distance is not constant, but when Neptune and Earth line up on the same side of the Sun at their closest, they are 2.7 billion miles or 4.3 billion kilometers apart. And when the planets are on opposite sides of the Sun, they can put as many as 2.9 billion miles or 4.7 billion kilometers between them. In fact, Neptune is so far away that it's the only planet in the solar system not visible to the naked eye. Also, no human alive today will see it complete an orbit. It went full circle for the first time since its discovery, only in 2011. However, a day on the planet is significantly shorter, as it completes a spin in just 16 hours. The only spacecraft to have visited Neptune is the legendary Voyager 2, which conducted a flyby in 1989 and took lots of photos as it made its way out of the solar system. That encounter was after dozens of years of traveling. Neptune is hardly a welcoming planet to humans, and it would be quite a nightmare if you somehow ended up on it. The planet has an incredibly thick atmosphere made up of 74% hydrogen, 25% helium, and about 1% methane. Its atmosphere also contains ice. In fact, it is the particles of icy methane and minor gases in the extremities of the atmosphere that give Neptune its striking deep blue color. The vivid blue and white features of Neptune also help to distinguish it from Uranus. Neptune's atmosphere is subdivided into the lower troposphere and the stratosphere, with the tropopause being the boundary between the two. In the lower troposphere, temperatures decrease with altitude. However, they increase with altitude in the stratosphere. you will find hydrocarbons forming hazes of smog in the upper atmosphere of Neptune, and hydrocarbon snowflakes that form in Neptune's atmosphere melt before they reach its surface due to the high pressure. However, one of the things you will notice after landing on Neptune is how cold it is. In fact, you might not have time to notice before you freeze. The planet is one of the coldest in the entire solar system. The coldest is actually Uranus. But just like the Earth, Neptune has its own seasons, which makes it have somewhat warmer spots. The average temperature at the top of the clouds is minus 346 degrees Fahrenheit or minus 210 degrees Celsius. Neptune does not have a solid surface like the rest of the gas giants. The gas just stretches down to the water-ammonia ocean that makes up the planet's mantle. But at the surface, which is the point that the surface pressure is similar to the pressure on Earth at sea level, the temperature is about minus 346 Fahrenheit or minus 201 Celsius. Neptune manages to be warmer than Uranus, which is closer to the Sun, because of the motions of the particles inside it. You will hear more about this movement in this video. However, Neptune has its own summer thanks to the 28.3-degree tilt. This gives the pole about 40 years of warmer temperatures. But that does not mean you can survive these summer years, as the temperature is just about 50 degrees Fahrenheit or 10 degrees Celsius warmer. During this period, methane gas leaks out into space. But this information did not prepare scientists for the strange discoveries concerning the temperatures on Neptune that scientists discovered. Before we get into this discovery, let's tell you about one frightening thing that awaits you when you visit Neptune: wind. Wind is good on Earth. It helps dry clothes and drives turbines to generate electricity. When it becomes huge, it becomes a hurricane, clearing everything from its path. However, on Neptune, it quickly gets out of hand. The planet holds the record for the fastest wind ever in the entire solar system. We are talking about wind speeds of up to 2,100 kilometers per hour. One of the mysteries scientists have not been able to solve is how a cold planet like Neptune can generate such strong winds. Their best explanation is that the cold temperatures and the flow of fluid gases in the planet's atmosphere might reduce friction to the point that it's easy to generate winds that move so quickly. And now to the recent in the line of perplexing discoveries scientists have made on Neptune. Ever since the Voyager flew past Neptune, scientists have been using giant telescopes to study the planet. Over the years, they've noted extreme changes in the planet's atmosphere. For example, between 2003 and 2018, average temperatures in Neptune's stratosphere plummeted by 14 degrees Fahrenheit. However, between 2018 and 2020, stratospheric temperatures in the South Pole suddenly shot up by a whopping 20 degrees. It was totally unexpected, which is why scientists are at a loss about what is happening on Neptune. But how do scientists measure the temperatures on Neptune as it is so far away? They track the changes by watching fluctuations in its brightness. Meanwhile, the brightness is not visible to the naked eye because it's in a light wavelength called infrared. These dramatic changes are unexpected because they're happening amid a profoundly long Neptunian season. Remember we told you Neptune has seasons? Well, the issue here is that the temperature changes are expected to occur during different seasons. They're happening amid the planet's southern summer and in the wrong direction. Temperatures are rising instead of cooling down. What could be happening? A group of researchers has said it's possible the Sun's 11-year activity cycles may be linked to temperature fluxes in Neptune's stratosphere. Another possibility is that the chemical changes in the planet's hydrogen-rich atmosphere may drive these abrupt alterations. One reason scientists are anxious to solve the mystery is that it will help them understand over 1,700 planets similar to Neptune, which they discovered outside our solar system. They are technically known as exoplanets. However, scientists studying Neptune will soon have a new powerful tool, the James Webb Space Telescope, the powerful observation station launched last year. This $10 billion telescope is just weeks away from going into full operation. It is equipped with instruments sensitive to changes in icy planets like Neptune. The only human-made object to visit Neptune was Voyager 2. It launched in August 1977, but could only make its closest approach 12 years later in August 1989. The visit has yielded many important facts about Neptune, increasing our interest in the cold planet. Because of the distance away from us, precious little was known about the planet until the advent of Voyager 2. However, when Voyager 2 started to observe Neptune in June 1989, even at a distance of 73 million miles, scientists knew they had hit the jackpot. At that far distance, they began getting images of the planet that were 4 times better than what they got through Earth-based telescopes. The approach quickly began to yield a trove of knowledge. For instance, Voyager 2 captured the moon known as Proteus, which orbits the planet at a distance of about 73,000 miles. Proteus has a diameter of 260 miles, which is larger than the known moon Nereid. Voyager 2 discovered 3 more small moons, Despina, Galatea, and Larissa, all on orbits even closer to Neptune than Proteus. Larissa had been spotted in 1981, but Voyager 2 confirmed its existence. The photographs of Neptune revealed a dynamic atmosphere, including an Earth-sized storm system named the Great Dark Spot. Voyager 2 also captured the first images of Neptune's rings. On closer observation, the rings were made up of 5 rings composed chiefly of dark dust. They stretch from about 40,000 to 63,000 kilometers, or 25,000 to 39,000 miles from the planet. The spacecraft also turned up 2 more small moons, Thalassa and Naiad. Like at Saturn and Uranus, the rings and 4 of the moons at Neptune form an intricate, interrelated system. The spacecraft also imaged Neptune's previously discovered moon Nereid at low resolution, about 3 million miles away. Voyager discovered that Neptune's magnetic field was not only tilted 47 degrees from the planet's axis, but also significantly offset from the planet's center. Just like planet Earth, there is a rocky core inside Neptune. However, the presence of a much thicker atmosphere cannot allow the existence of life as we know it. Astronomers are still trying to figure out at what point a planet is so large that it may pick up a lot of gas in the area, making it difficult or impossible for life to exist. Neptune is fascinating for many reasons, and to start with, scientists have discovered it was way closer to the Sun at some point in its existence. They arrived at this conclusion because the amount of gas and ice needed to form the giant planet is greater than fits current models, so Neptune most likely formed closer to the Sun, then migrated out to its present location over time. Voyager conducted its closest flyby of any planet when it flew 3,408 miles above Neptune. This close encounter allowed it to get as close as 25,000 miles to yet another moon of Neptune named Triton. The flyby of Triton was significant because it was the last solid body the spacecraft encountered on its journey. However, Voyager 2 took and transmitted stunning photos of Triton, allowing scientists to make amazing discoveries about the moon. For example, astronomers discovered that with relatively few impact craters, Triton's surface is quite young, having been remodeled by melting. Also, despite Triton's frigid -392 degrees Fahrenheit surface temperature, Voyager's images revealed evidence of geysers spewing dark material into the moon's tenuous atmosphere that deposited back onto the surface. Triton is one of the coldest places in the solar system. Voyager passed behind both Neptune and Triton, with instruments returning data about their atmospheres. The spacecraft also returned spectacular images of the 2 bodies backlit by the Sun. On its outbound journey, Voyager 2 continued to study Neptune until early October 1989. In all, it had returned more than 9,000 images of the planet, its rings, and its moons, as well as a treasure trove of scientific information, tremendously increasing our knowledge of the most distant planet in the solar system. Astronomers used to think Neptune was too cold to allow atmospheric disturbances, but Voyager 2 discovered large-scale storms, most notably the Great Dark Spot. It turned out to have a much shorter duration than Jupiter's persistent Great Red Spot. Neptune not only has storms, but it also happens to have the fastest winds in the solar system. Because of its great distance from the Sun, Neptune gets little sunlight to help warm and drive its atmosphere. However, the winds on Neptune can reach up to 1,500 miles per hour, or 2,400 kilometers per hour. This led to lots of questions about why the winds were so strong. The strong wind, however, was not the only thing puzzling scientists about Neptune. Its temperature was also a mystery. Voyager 2 revealed that Neptune is warmer than Uranus despite being farther from the Sun. The conventional wisdom was that the farther you go from the Sun in the galaxy, the colder it became. Yet Neptune had more heat than Uranus. The question is, where is the heat on Neptune coming from? As physicist Brian Cox discussed in his BBC documentary The Planets, the source of this extra heat remains a mystery. However, the bigger puzzle was whether the 2 usual behaviors, that is, the strong wind and the elevated temperature, were in any way tied. Some scientists even speculated that unraveling one mystery would explain the other, but how would this be achieved? Measuring Neptune's temperature, however, is not so straightforward. For example, on Earth, you can take measurements on the solid surface and calculate the global average. If you must take a temperature of Neptune, it has to be at an altitude. This is where you need to make another decision. At what altitude will you take the measurement? There is something else about the temperature measurement taken by the Voyager 2. Obviously, it took the temperature from the outermost layer. At that point, the temperature of Neptune is not so much higher than that of Uranus, but since Neptune receives less solar illumination because it's farther from the Sun, this shouldn't be the case. What this similarity in temperature suggests is that Neptune is warmer in terms of how much heat it emits in comparison to the amount of heat it absorbs from the Sun. According to Anthony Del Genio of the NASA Goddard Institute for Space Studies, Voyager's measurements show Neptune emits more than twice as much heat as it absorbs from the Sun, while Uranus does not. This doesn't make Neptune unusual, though. In fact, it makes Uranus weird because other planets like Jupiter and Saturn also emit more heat than they absorb from the Sun. As stated earlier, the progression of temperature as you go farther away from the Sun shows Jupiter to be the warmest of the gas giants, Saturn next, then Neptune. Uranus is the one that is out of place. Del Genio explained the oddity further. Yet that unusual result is associated with the fact that Uranus does not have a significant internal heat source. In other words, Neptune is finding a way to warm itself up to the levels of Uranus, while the latter is unable to generate any extra heat other than that gleaned from the Sun. But just what is an internal heat source? In simple terms, it is heat left over from the birth of the solar system when these planets were formed. The heat contracts out of the primitive solar nebula, forming an effect known as the Kelvin-Helmholtz contraction. The extra heat source on Neptune, Jupiter, and Saturn is primarily due to gravitational contraction. As the planet slowly gravitationally contracts, the material falling inward changes its potential energy into thermal energy, which is then released upwards out of the planet. For Uranus not to have such a heat source, something must have happened to it. So the question is, why does Neptune produce heat internally but Uranus does not? There is a possibility that heat is not released from the interior at a steady rate, but instead comes in burps. According to Joshua Tollefson of the University of California, Berkeley, we may just be seeing Uranus in a quiescent period, whereas Neptune has burped more recently. The burps are convection, which may happen in discrete episodes separated by long time periods, but we may not know if it works this way for sure unless we see one of these convective episodes take place. Or it could be an issue of Uranus being an old-timer and Neptune younger. Amy Simon, a NASA senior scientist for planetary atmosphere research at the NASA Goddard Space Flight Center, explains, how much heat a planet radiates depends mostly on how old it is and how quickly or slowly it releases that heat. An older planet would be colder. How quickly they release depends on the interior structure and composition, cloud layers, convection, and so on, and that can be rather complicated. NASA scientists are painfully aware that a single flyby by the Voyager 2 is not enough to explain all the mysteries locked in planet Neptune. To remedy this, a group of scientists named Conceptual Exploration Research, CONEX, have proposed a spacecraft called Arcanum. The Arcanum mission is a proposed L-class spacecraft that highlights the revolutionary approach which can now be taken to future space mission design. Weighing in at about 21 metric tons, the spacecraft would be 4 times heavier than the largest deep space probe to date, NASA and ESA's Cassini-Huygens mission, which explored Saturn from 2004 to 2017. CONEX's Arcanum would have numerous components, including an orbiter to study Neptune, a lander to study Triton, and a penetrator to strike Triton's surface and perform a seismic experiment to understand its geology and its structure. The mission could also be equipped with a telescope, allowing for studies of the outer solar system and aiding the hunt for planets around other stars. However, the problem is that there is no existing rocket that could currently launch such a craft as CONEX's Arcanum. When scientists face problems like this, they try to work around them. For example, equipment such as NASA and ESA's upcoming James Webb Space Telescope must be launched folded up and then unfurled. But the process is expensive, complex, delicate, and could be prone to error. A single mistake due to the complexities could send billions of dollars and numerous person-hours up in smoke. This is where Elon Musk comes in. Much has already been made of Musk's Starship's human spaceflight capabilities, but the rocket could also revolutionize what we know about our neighboring planets and moons. According to Ali Bramson, a planetary scientist for Purdue University, Starship would totally change the way that we can do solar system exploration. Planetary science will just explode. Scientists are already talking about sending missions to Neptune and its largest moon in the outer solar system, bringing back vast quantities of space rock from Earth's moon and Mars, and even developing innovative ways to protect Earth from incoming asteroids. The Starship, which is being built at a Texas site dubbed Starbase, is made up of a giant spaceship on top of a large booster known as Super Heavy. Both can return to the Earth to be reused, reducing costs significantly. SpaceX has suggested launches of $2 million only using the Starship. With a drastic reduction in costs, more funds can go towards the actual equipment for the scientific experiment or exploration rather than to the transportation. The entire vehicle will be capable of lifting 100 metric tons or 220,000 pounds of cargo and people into space on regular low-cost missions. The volume of usable space within Starship is a massive 1,000 cubic meters. You can fit the entire Eiffel Tower into the Starship payload area when the tower is disassembled, and that's got scientists excited. For example, you can transport a whole drilling rig to Neptune using the Starship and drill down a kilometer as possible on Earth today. This will afford scientists unprecedented access to the interior of the planet. Starships is like wow, says James Head, a planetary scientist from Brown University. In fact, Connex proposes sending the Arcanium to Neptune aboard the Starship. Musk has suggested that SpaceX could launch as many as a dozen Starship test flights in 2022, with missions to the Moon and Mars both on the horizon, and plenty of scientific potentials to boot. Once Starship starts flying, the development will be very fast, says Margarita Marinova, a former senior Mars development engineer at SpaceX. There will be so many more people who will be able to fly things. Those could be anything from standalone missions using Starship to ride-along missions on the existing flight manifest. When you have a 100-ton capability, adding on science hardware is pretty easy, says Marinova. If somebody wants to buy payload space, they can have payload space. It will be a really drastic change in how we do science. Because Starship can land back on Earth, it will also theoretically be able to bring back vast amounts of samples. The sheer volume that could be returned from Neptune would give scientists on Earth unprecedented access to extraterrestrial material. That could shed light on a myriad of mysteries, such as the planet's volcanic history. One of the things that makes the Starship suitable for NASA missions to deep space like to Neptune is the method of refueling. Unlike other Super Heavy rockets like NASA's much-delayed Space Launch System and Blue Origin's New Glenn rocket, the upper half of the rocket is designed to be refueled in Earth orbit by other starships, so more of its lifting capability can be handed over to scientific equipment rather than the fuel. Taking humans to the Moon, for example, might require 8 separate launches, with each consecutive tanker Starship bringing up fuel to the lunar Starship that then makes its way to the Moon with scientific equipment and crew. On a mission to Neptune, the Starship will replenish all the fuel spent during the escape from the Earth and then proceed to the planet on full tanks. Musk is even proposing having fuel depots on other planets where the Starship can stop to refuel, just like you stop to refill your gas tank when on a long trip. This is ambitious, but it makes missions to planets like Neptune or moons attached to Jupiter more feasible and less complicated to coordinate. Let's hear what you think of NASA using the Starship in the comment section below.